Hello everyone, Mr. John from Areteem Institute with this week's Thursday Tidbit. Today we're going to be quickly looking at a sample problem from the ARML math competition. The ARML is an in-person competition. ARML is the American Regions Mathematics League. It's being held the next 2 days, so June 2nd and 3rd, I think starting tomorrow evening, and then going into Saturday morning that way as well. Students are competing across the country, but all in person and in one of 4 different locations. Actually, our very own Dr. Wang is coaching for the Southern California team, and will be helping that team in Reno, Nevada at the University of Nevada that way as well. So I want to give a good luck to all people competing, and if anyone's interested in learning a little bit more about the problems, we are going to do one quick individual round question today in this video. There are different team rounds, stuff like that there as well, but just as a little bit of a flavor, let's look at one of the questions from last year. Now, one of the things that's different than the AMC competitions, AIME competitions, if people are familiar with those, is for all of the rounds, for the most part, you have kind of short answer, right? Numerical answers, but they don't necessarily have to be integers. They could be fractions, things like that as well. So let's see that come into play with a quick geometry question here. We have a bigger circle with a radius of 4. We have a diameter. We have some smaller circles of radius 1. Everything's tangent. They're kind of tangent to the diameter AB. The circles are tangent. And the question here is trying to determine PQ. Now, this isn't anything special for ARML or things like that, but just general problem-solving strategies here. Well, first of all, you want to make a list of all of the important details. And for geometry questions, I can't stress enough that a nice big diagram is helpful. So for this question, we have it prepared, cheating a little bit, but summarize what is important. And in a lot of cases, you maybe don't need to talk about all of those details. So as far as the question is concerned, it's enough for me to say, and I know we should know what it means. The circles are tangent, right? Tangent to each other, tangent to the line, that diameter there, right? We know that AB is the diameter. So I'm kind of summarizing here what is the important information from the problem, and then drawing a nice big diagram that we can work with and consider there as well. Now, anytime we have circles, it's good to think about circles and centers. AB is a diameter, so we definitely know that the center of that big circle is on that line there, right? The midpoint of AB. So we do know that, for example, AB is 8, right? Just to remind us of the radii, things like that as well. For these small circles, let me kind of draw their centers in 2. We know those radii are 1 there as well. And anytime we have centers, it's good to draw radii as well. And actually, this whole question, for the most part, comes down to the following radius right here that we can draw there. Now, a couple of things that are important to mention from this kind of setup there too. And in fact, this circles are tangent is our key piece of information there. What does it matter that those circles are tangent? The circles are tangent is what's telling us actually that that radius goes through the center of the small circle. Because they are tangent there, we actually know then, that full radius is 4, So this distance here is 1. We have another distance 1 here, and we have another distance 2 that way. The other thing that gives us, I'm not going to draw an arrow, but I will label the part in orange, is if we draw the radius down to point Q, actually that is a 90-degree angle there as well. So we actually have kind of a pretty quick way of solving this from here then as well. So let me label this kind of center of that circle O, right? We know then that OQ, right? And maybe let me give another point here a name too. Let's call this point kind of C, or maybe D in this case. So we have OQD is actually a right triangle. So kind of triangle OQD is going to be a right triangle there. So Pythagorean theorem gives us something pretty nice, right? OQ squared, I'm not going to label all the points here, plus 1 squared, because we know that QD, that is another radius of that small circle. So that plus 1 squared is equal to 2 plus 1, or 3 squared there. So we know that OQ squared is 9 minus 1 is 8. So OQ is 2 square root of 2. Square root of 8 written in simplest radical form gives us that 2 root 2 there. And what about PQ then? Well, PQ, we can repeat the same thing on the other side. So if we know that this is 2 root 2 here, right? I'm not going to do the diagram, but the same exact thing happens for PO. So this is 2 times OQ. Whoops. And therefore we know that is 4 root 2. And we are good. So pretty quick question, but a good example geometry question. Draw out the diagram. What do you know? How does that help you? And oftentimes that can lead to a fairly simple, fairly straightforward solution there as well. Okay, like I said, just one quick question this week. So thank you all for watching. Stay tuned for a new idea back to the normal Thursday tidbits next week. If you have comments, ideas, requests, let us know down below. Give us a like and a subscribe if you enjoyed this video. Otherwise, I will see you all next time. Goodbye.